This conference will now be recorded.
Okay, so let's start. And we have already covered, the initial sections of Amazon Elastic Compute Cloud in one of my earlier video. The description link is below. And so let's go continue to the review section. So now we comes into, obtaining the billing information, So the billing is most of the important field, and because what happens, like you're an account manager, let's say, and under you have 10 different accounts catering to the different departments, and you have not, worked in provisioning the AWS resources correctly, and you just let it, go and work, and you did not follow, certain AWS frameworks as best practices. So what happens, like, that your bill can go to astonishingly high. And so for an organization to run smoothly in terms of, the bill, this needs to be this piece of the info, and has to be properly controlled, managed, and this thing. So this section is particular about the AMI which you are using. So you have an option to see the billing information related with this AMI. So what happens when you get into the Amazon console and you have the platform details, and then you can see the billing code, and then users operations, and then the further details, and this is the way you can go to the Amazon console, log in, choose your MIs, give to the detail tab. In that you have the platform details and the users operations, and you can also use AWS CLI prompt, and get this detail, and this is basically the output. And then and then there are other ways, you can still go from the instance and then see it. And then you can, based on this thing, you can read. So just if you read this, like that, for an example, the AMI, the AMI number has the following billing information: platform detail, Red Hat Linux, users operation is this. If you launch using, you can find your instance ID, and it's the value. So based on that bill, you can just see your billing information. And this is an how do you deregister your Linux AMI? Basically, like, how do you shut it down completely? And this is the standard diagrammatic this thing. So what happens, like, this is what it is running. This is your EC2 instance. This is your AMI based on which this EC2 instance got. And this is the EVS snapshot of root volume and EVS snapshot of data volume. So when I say snapshot, it's basically a copy. You do deregister the AMI, then your EC2 instance runs, and then you have the snapshots. Then you delete the snapshots, the only. And so once you are done with this, then only you can terminate it. So basically, like, as a step process, you go to the Amazon cancel, go to your AMI, go to the snapshot. So basically, you first delete the snapshot, and then first you deregister the AMI, then you delete the snapshot, and then you are able to uh, terminate it. So this is also one of the, the basic on the go question for AWS interview, where you delete the snapshot. Basically, you delete the AMI, then you delete the snapshot, then you terminate the instance. Right. So this can be asked, I mean to say, this is the very this thing. So same for, cleaning up the instance stored backed by AMI. So if you see that this diagram, you have your AMI, and its copy is in, in one S3 bucket. You deregister the AMI, then you delete the bundle, and then you can terminate your instance. So you can also do through AWS CLI, and the choice is always based on the person. So initially, if you're new to this, I would suggest go through the console, GUI console. It will be easy for you. So same for Amazon Linux. Then, yeah, these are the two distribution, Amazon Linux 2 and Amazon Linux AMI, provided by AWS at no cost. Basically, like they don't take the money for where the, you know, it's running the infra part. Then you connect your this thing. Then this is the, how do you identify an Amazon Linux image? You have to understand this. Although it's not required, it's a one time. I do not need to remember, but this is where if you want to identify about it, you go to the etc image ID, and then you read this detail. If you do it the cat here after login, it'll give you the most value. So generally like in your day-to-day time, you will focus on this. And I think, yeah, I think primarily the version number, those two things should be this thing. And then we do OS release, it will give you basically, okay, so it's a CentOS RHL Fedora. And so what it means, like the base, whoever created this AMI took this and then they customize it to Amazon standard. Same way, if you do it, you get all these details, and then these are the command lines. And generally you don't require it. I mean to say, yes, you should know it, there is a way, but you don't need to remember this, because the thing is like, okay, because unless you are just doing the work of provisioning the instance all time, then it's good. But if you are like a solution architect, I don't think so this is required. And then this is the command. And so these are like self-explanatory command, if you read it. And this is basically a command. How do you do it? So what happens, like when you see a dollar sign, it's like in your ID. When you give a sudo, so basically you are because install command always run through an admin one, and sudo. So there is a another high level where users are added to a sudo list. So basically what happens is, without changing to the root, it can be done again. This is made to sure that the person do not require a root privilege, because if the root privilege is required, and the consequences. So there are security updates. These are provided using the package repository, and then you have to there is a way to configure it. And yeah, so basically this you need to follow the document. I mean to say, like there is nothing, whatever the document, the command it says, but just you need to know where to go. So for an example, you need to know that you need to get into the console, you need to get into the user which has the sudo privilege and which has the yum command running capabilities. So once those things are done, you need to follow up the steps, and then just do the installation as and when, based on this thing. So typically, like most of the time, it's remain automated, or there would be a set of the admin people, who would do the things. But it's not something, people who are using it will do it. It will be a separate team altogether. But yes, having an info is. So generally, you don't require to subscribe for Linux notification as a solution architect, because that's where the focus would not be. But if you want, you can just go to the subscription panel and do all those things, and there is a way to unsubscribe it. So basically what it does, I think it will try to give you the notification of anything happening across those instances and the Linux machines and the info. So yeah, now there is a way, how can you run Amazon Linux 2 as a virtual machine on premise. So basically these are the steps where it says that prepare the ISO boot image file. How do you do that? So in the existing server, you create a folder sit config, and then you copy it, and then you give the network details, then you copy the user data informations, and then you save it. And then this is a command which do not require a sudo Linux command. You do this, and once you do it, so let's say for an if you're at the Mac OS level, you have to do the STI util. But if you're in the Linux, you have to do like this, and then download the Amazon Linux image, and then there is an option how to boot it. So once you have an ISO file, I think that pretty much people knows how to boot it. So something, just an additional info. You do not need to do it. So kernel live patching, so these are done by the support people. They are generally do for security updates and bug fixes. And so basically what happens, like if you see the cat etc OS release, so it's basically like CentOS, Red Hat, Fedora, so those patches come from there. Amazon itself will have something, but mostly it will come from the base kernel creator, and then those needs to be applied. And it is called kernel life patching. The reason is like, when you say something like this, enable kernel life patching, it means your OS is up and running, and there's this instance is up and running. You do not need a downtime, and you can do it. So then there are certain commands which you so this is like bin util. It is like, a library file, and then you just follow the command. And even if you know it, the suggestion is to follow the steps, because these are standard steps. The difference is like, if you're in a Windows, you just click next, next, next. But in the Linux and all, you have to follow these steps. So these are something, industry standard accepted step. So you do not need to remember this, but yes, okay, this thing happening. So there is a, another thing where, a user can come with their own custom kernel. So these situation occurs, when let's say an example. For an example, there is an HP machine, HP printer, and they say, hey, my only work from this machine is to accept a request billion in numbers and deliver it. That's the only work this has to done, and nothing else. Now, when a kernel comes, it has so many other utilities for most of the things like printer, sound, video, and database, open source. So for HP, they don't need all those things. They just need that, let's they don't need it. They just need that one particular functionality. So what they will do, they will just customize their kernel and remove the unnecessary libraries and all. And and they will use it as a standard. So the benefit what it gives, like, that the other processes, if they are there by default, it will be up and running somehow, somewhere at the very kernel level, and it will consume the CPU part, even for a minute or second. So it's all about, performance optimization and the performance. So the users are not requested, given an option, that they can come with their own custom kernel. And then there is a steps how to do it. So you have to follow it. It's like a one-time activity. The only thing was a solution architecture you need to know, when that yes, it is possible. And then there are for certain limitations, and it's a one-time activity. It's not something you are doing every day, but most of the time, considering the today's computing capacity, these are not generally touched by the people, and like, they go with as usual, and they are able to make it. So there are also, you have to follow this page, just you need to know that yes, it is feasible, but you have to follow the page. So there is a Met desktop service provided by Amazon Linux 2, which has .NET, PowerShell, Mono, and this provide a graphical user interface for administrating Amazon Linux 2 instances without using the command line. And yes, so there is a way how to do it, and maybe I think it's more of a VNC servers remotely you connect and just do it. So yeah, then there are a few questions, like let's now I think, yeah, let's come to, the so till now whatever we did, we went for the high level of the info. Now this is the basic thing, let's break down at the instance level. So there are three questions which can definitely come to your mind, that what instance type best meets my need. So what Amazon says, like, they have an option for choosing CPU, memory, storage, and network capacity. They have an option, purchasing option. So they have a spot instance, on demand, reserved, root volume. They have an option that you go with Amazon EMS or backed by Instant Store. Then you have an option, that can I be able to connect securely to my EC2 instance from remote? And yeah, so then these are the questions. So instance types are what? There are many instance where is like, okay. So these are the numbers you do not need to remember, but I will say, like, just for example, T2 macro. So you have to always follow these chart, and then based on that, when you click launch instance, you have an options to choose this thing. And as the name suggests, so it falls into C5N category: large, extra large, 2 extra large, 4x large, 9x large, 18x, and metal, and then these are compute optimized. So basically what it means, like, these different types of the servers are catering to the different sectors of the digital arena, or maybe different sectors of like uses, and these are highly customized for different types. So you have to see that you are trying to do the solutioning for which type of industry, and based on that industry type, you need to yes, you need to decide, and definitely there is a cost associated with it. And for example, let's say if you want to go for a satellite, generally what happens with a satellite, the video is recorded and it is being uploaded. If it is not a live program, so it is being uploaded. So you need a server, which can help you in that type of transmission. You have to upload, maybe 36,000 kilometers above, and that server would require a different type of computing rather than transferring the same data across over the over the wire or local area network. So I'm just giving examples. Let's for telecommunication, 5G, you need different types. So basically what happens, like, as and when yes, you need to review it, just you need to know it right now, and then you have to explore it maybe 1 hour, 2 hours, and then once you prepare your solutions, you can just mention this is the instance, and then you can give a description, this is what I suggest or you suggest, and then there are previous generation, then there is a hardware type, and then there is a virtualization. So there are two virtualization, this is para virtual and which is hardware virtual. So you need to know these things, and there is a there is an option for Nitro system. What it does, it is a collection of AWS built hardware and some software components that enable high performance, high availability, and high security. So it has all the performance will be high, availability will be high, security will be high. And these are the components. It has a local storage, network support management, chip, Nitro supervisor. That what it does, it manages memory and CPU. So basically what happens, like what Amazon has done is, based on all the different types of the hardwares available in the market in and out, they have got into the best combinations possible from each of these combinations, and then they have come up with the more flexibility to an end user to get away from the performance issues that might come. Because what happens, like, when you say that I'm going to provide a solution to any line breadth of the industry, you need to have, very bunch of hardwares and all those things which can work for you. Healthcare would need something different, travel would need something different. So what they have done, they have come with all those, the best of the best in each of these industry and put it all in it, and then based on the costing and all whatever it takes, and so that a solution architect can choose it. Then networking, so IPv6 is supported for all current generation, and so they are saying if you want to maximize the network and a bandwidth, launch supported instead, type in a cluster placement group. Okay, so this could be one question, that how do you improve network uses? And so this is going to be one. Then you say enable network, enhanced network for supported current generation. So you can search for more, because see what happens, like if you go here and if you speak this very confidently, then a person can ask another question from your keyword. So you need to know that. Okay. So then there is a fundamental of this. If you are in the same region, you have get a 5 Gbps or single flow traffic, or up to 25 Gbps for multi-flow traffic. Okay, depending on the instant type. Okay. Uh, yes. So in general, like pretty much all are already in a very highly optimized performed status. But yes, knowing certain info can definitely help in you preparing better solutions. So for storage, you have a EVS, you have a store, and then yeah, and then you can refer this, this table to get a better understanding. and then plan accordingly. Once your architecture gets finalized internally, or maybe the draft version gets finalized, so you can just suggest, based on this is what it is. Then this is what is the instance stored is SSD, and this is the server name, placement group, and then instance limit. There is a limit on the total. There are additional limits. So there is a limit, that how many instances can you launch in a region. So we'll see. Yeah. So there is a general purpose instance, which is, and on this you call A1 instance, which is like a web server controlled as microservices. Then M5 and M5 fall on a small and a mid-size data processing, caching fleet, backend server for SAP. So basically these are the server names, and then you have MG6, M6Z8. This falls for application server, microservers, gaming servers, mid-size, caching fleet. So what it means, like, if I'm doing a solution for microservices, I should suggest M6Z and M6ZT instances. Then I have a T2, T3, and T3, which are for websites and a web code repository, development, microservices. And then there is a descriptions, let's say you go for M6. Okay, M6 series is, okay, let's scroll. Yeah, so it starts with 8 gig, and then it goes till 256 gig. So you have to decide which series you want to go. Then instance performance is like what this is, that you go with the EBS volume, and it gives you the better performance for network. Then there is a, based on the instance, there is a network capacity chart. And definitely you need to, when you do the system design, you will just do these calculations first, which is like network performance, and based on that is automatically you come here, and let's say you go on to 25 Gbps of volume. You come here, and then based on this table you go up to here and check how much RAM is you want. And then if you have an existing prod running, you will definitely able to correlate, hey, mine existing 128 gig is there, this is the configuration. And then in this you want to match which of these tables you can use it. So this is the way I would say, from system design to solution architecting you can go. That's the one way. And then same way, when you calculate these values from the existing environment, or when you try to anticipate what could be the input output rate based on the business requirement, you have to follow this. So you make a calculation which instance size or which instance type you have to use based on these key parameters. And these are done when you have gathered the requirement from end users, and now you're in a phase where you have to plan for solutioning part. Okay, and then once you do these, then you further check here. Okay, and then you decide, okay, based on these graphs and these yeah, so first EBS, okay, fine, go here. Instead, I'm not going here. Oh, I need a placement group. Okay, EBS, and if I choose this, okay, I do not have this. So the point is, like, if based on all your previous calculation, you come with this, and you see, okay, you can't go with this, you have to always choose higher version than this. Okay, so what will happen, so the basically is like, if you choose higher version, at least you can remove the bottleneck tomorrow. Okay, and then based on the user, those capacity can be. So initially the objective is that initial days you get a better service to your end users. Okay, then these are the notes, and there are further details. Okay, now see, then there is a was stable performance instances. What are those? It falls under T3, T3A, and T2. And these are provided for a baseline level of CPU with the ability to burst to higher level one required by your workload. So what does it mean? If you choose these, then by default, it will be guaranteed that, okay, this much of this baseline CPU computing we will get. But if you have a requirement which increases, it will suddenly get you to the higher level of workload. So, and this can be used for general purpose application like microservices, low latency, small and a medium, virtual desktop. development, build, and stay. So in case I would say like a virtual desktop, what happens like you have 100 people all connects to the virtual machines and definitely all starts working. Suddenly you can just estimate like that if you have your own laptop or a desktop and you run 3 4 programs, the fan starts running, the temperature rises, and you can, if you don't have much of computing power, you can feel the slowness. But the same thing if you have 100 user, end of the day they would be running on some machines and you get an image of it, right? So they need then I'm just giving an example real life, where you can go with the bus stable performance instances. Okay, so there is a option, you can have it on demand, you can have a reserved, you can have a dedicated, can have a spot, but not as a schedule. So and they are also not supported as a dedicated host. Okay, so you have to fall in either of these, and somewhere they do not want to get into dedicated host because they anticipate these machines are of high capacity. So if the organization has lots of money, because managing and maintaining these machines do cost much, and based on the usage, I think the computing power and all those things, the price varies up. So if somebody gets a dedicated host at a very one go, um, then somewhere it will not help. So so I think AWS must be thinking, if we give as a dedicated host, then down the line, people will try to just go for that and will not bother much about it. you know so they just removed it, so it's all about like a need basis. And then there are further requirement for this thing, graphical and memory. And then the best practices is like that you use a recommended AMI. I use that AMI that provides the required driver, and turn on the instance recovery, like create a cloud watch alarm that monitor an EC2 instance and automatically recovers it if it becomes impaired for any reasons. Okay, so now it comes like CPU credits and baseline utilization for burstable performance instance. So it says like traditional Amazon EC2 instance types provide fixed CPU utilization, while burstable performance engines provide a baseline level of CPU utilization with the ability to burst CPU above the baseline level. So if you go for the non-burstable performance instances, you get a fixed CPU utilization. But if you go with the burstable performance instances, you get a fixed, and then it goes beyond. So CPU credit provides for. So basically, this could be a question: what is a CPU credit? This is this could be one of the AWS interview question. So if you have like 100%, so 100% you can utilize for 1 minute, and then there is another combination. So basically, what happened, like you have to follow this chart and understand it. Let's say you choose a T2 Nano machine, you get a 3 CPU credits per hour. You can have a maximum of 72 credits. Virtual CPU is 1. 5% is baseline utilization per virtual CPU. So what happened? Let's read it. Each versatile performance instance continuously earns at a millisecond level at a set rate of CPU credits per hour, depending on the instance size. The accounting process of whether credits are acquired or spent also happens at a millisecond level resolution. So you do not have to worry about overspending CPU credits. A short burst of CPU uses a small fraction of CPU credit. If a versatile processor uses fewer CPU resources than it is required for baseline utilization, such as when it is idle, the unspent CPU credits are acquired in the CPU credit balance. If a versatile performance needs to burst above the baseline utilization level, it spends the accrued credits. The more credits that a burstable performance occurred, the more time it can burst beyond its baseline when more CPU utilization is needed. So see what happens here. Okay, let me explain you. So what does it mean? It means you chose T2.nano, you're earning 3 CPU credits per hour. Maximum you can go to 72, and you have a one virtual CPU. And let's say this T2.nano is shared by this machine is shared by maybe 5 users, and you are subscribed to burstable instances. Now you have a 5% baseline utilization. So the point is your baseline is 5%. So in 1 hour,